Alright, hopefully you've had a go at watching that video now and you've realized some of the problems that we have with natural language algorithms, and you would have outlined those in this text box right here, watching the short video and then outlining some of the problems. So some of the solutions that software developers have come up with to represent algorithms more precisely, they came up with precise languages or precise descriptions that translate more nicely for a computer. So one of the ways that they use is called pseudocode. Now, pseudocode sounds like English. It uses English-like statements, but they have defined rules about how to use the structure and keywords which you need to use in order to increase clarity and show how the structure of the program runs. So some of the rules for structure in pseudocode are keywords have to be written in capitals. If you start with a command, then there's a corresponding element that you need to end with. So for example, there's a begin command, and for every begin there has to be an end. If you start with an if, there has to be an end if, and that shows where the if statement starts and where it finishes. Indenting is used to identify the segments of code or the control structures in the algorithm, and if you're using a subprogram, then subprograms are underlined. On the next page are the keywords for pseudocode. So you can see here we've got begin and we've got end, and what you would do after the begin keyword, so the keywords are written in capitals, remember, is you'd write the name of the procedure. So if you were writing a procedure for get out of bed, then you'd say begin get out of bed. You'd write all of the instructions about how you go about getting out of bed, and then at the end you'd say end getting out of bed. If you were making a decision within your procedure, then you'd have two types of decisions. The first type is called binary. That means you've only got two options. Binary means you've got two options. And so if the condition is true, then you might do these statements. Otherwise, you might do these statements. However, the other type of decision that you've got is a multi-way decision. Okay, that's where you might have multiple different options. So for example, if you're looking at the weather outside, you might say if it's sunny and the temperature is above 20 degrees, then we're going to go and play soccer. But if it's sunny and the weather is less than 20 degrees, we might go for a walk in the bush. If the weather is rainy, then we're going to stay inside and play games. If it's snowing, we're going to go outside and ski. And so you've got a number of different selections. A case or a multi-way selection also has this last option where you've got an otherwise, where if none of the above are true, then you've got a default process that you can follow through. For looping, so if you're wanting to repeat something in your algorithm, there's two different types of loops. There's this one which is called a pretest loop, and you start a pretest loop with a while statement. And so what that does is you test a condition. So you might say, while it's not raining outside, we'll continue to play. And then you'd have your end while. That would mean that there is the possibility of you never getting into the statements in the middle. So it might already be raining outside, which means we won't ever go outside and play. Whereas with a post-test repetition, we might say repeat, play outside until it's raining. Now because the test is after the statements, it means that we have to go and play outside even if it is raining, and then if it is raining, we have the option of coming back in. And so there's two different types of repetition there as well. And then this third repetition, which we've already used, we used this in one of our C# codes programs we've already written, is a counting repetition, so an iterative, where you want to do something a number of times. And so this is the structure in pseudocode that matches that type of iterative repetition within C#. The second type of algorithm that we've got is a flowchart. And so flowcharts, instead of using keywords, flowcharts use specific shapes to try to identify the purpose in an algorithm. So within a flowchart, just like there's a begin statement in pseudocode, there's a begin shape. So you can see this rounded rectangle represents the start and the end point of an algorithm. And so inside that shape, you'd normally write the name of the process, the name of the algorithm, what it is you're doing. So you might put in here, get ready for school, and then you'd list the different things that you need to do to get ready for school. each of the actions in getting ready for school is called a process, and so those are put inside these rectangles. When you make a decision, we put it inside a diamond shape, just like that one there. And so these are normally, rather than being an action like a process, a decision is written as a question. Okay, is it raining? And then you'd have a true or a false flow line to follow. A sub-process or a sub-program is something that's defined in another algorithm. So if you see one of these in your algorithm, which is a double-sided rectangle, then it means that there's another algorithm that describes how to do this process. And that allows you to create modular programs where something that you do over and over and over again would be defined in its own algorithm, so you don't have to rewrite those statements multiple times. You can just call that subprogram, and that means that it will do the steps that are in that subprogram at that point. Alright, so those are our different types of algorithms that we're going to use within this course. So we've got flowcharts and pseudocode in order to describe processes or plan the processes that are taking place within code for our programs.